All right, we're going to go ahead and get started. Good afternoon or good morning, everybody, depending on where you're calling from today. So welcome you to a webinar brought to you by the SF6 Emission Reduction Partnership for Electric Power Systems. My name is Vola Roshanka, and I'm with the U.S. Environmental Protection Agency, where one of my roles is to manage this voluntary partnership with industry. I want to thank everybody for choosing to spend the next hour and a half with us. I know there are a lot of webinars going on right now, and you all have choices, but we do have a very exciting and packed agenda for you today. We're excited to present you this webinar with very esteemed speakers on SF6 free alternative medium and high voltage circuit breakers. Before we get started, I do want to go over a few housekeeping items. The webinar is recorded and will be available on the PPL Partnership website. So please mute your lines, also turn off your videos, and we will hold a question and answer session at the end of the webinar unless there are quick clarifying questions that the speaker can respond to quickly. Please submit your questions via the chat, or if it's not available to you for some reason, then you can email the email address that you see on the screen. And we will compile all your questions as they come in, and we'll do our best to cover them at the end. However, if we do not answer your question, please feel free to email. We'll try to do our best to get back to you. And I will start by making a brief introduction to the partnership, especially if this is your first time interacting with us. The partnership is a joint voluntary effort between US EPA and the industry to reduce emissions of sulfur hexafluoride through voluntary, cost-effective, and technical management solutions. SF6 is a man-made gas that is emitted from electrical transmission and distribution equipment, manufacture of electronics or semiconductors, production of magnesium. SF6 stays in the atmosphere for about 3,200 years, so it has one of the highest global warming potentials compared to CO2 over 100 years. So it's about 23,000 times more potent than CO2. And the partnership was formed in 1999 to address this problem of ever accumulating SF6 together with 45 charter partners from the electric power industry. And EPA and our charter partners decided to work collaboratively to find cost-effective solutions to reduce emissions of SF6. And the partnership currently totals 90 partner utilities that represent approximately 50% of total US grid transmission miles. In 2018, nameplate capacity of SF6 of our partners was over 11 million pounds of SF6. And our goal is to create a technology and company neutral platform for utilities to discuss best practices to reduce emissions of SF6. As such, we do not endorse any companies, including any mentioned here during this webinar. Over the last 20 years, the partnership has been working to voluntarily reduce emissions of SF6 and disseminate best practices in doing so. Collectively, partners helped achieve a 78 reduction in SF6 emissions and an 88 decrease in emission rate among partners compared to a 99 baseline. So in absolute terms, partners have collectively reported a cumulative reduction of nearly 8 million pounds of SF6 in that time period, which represents a substantial improvement from where the industry was in 1999. However, as SF6 stays in an atmosphere for a very long time, it is accumulating and concentration of SF6 continues to go up, so our efforts continue to be relevant. In recent years, the partnership has focused on delivering technical products to the industry, such as a report on best practices in reducing emissions of SF6 from the electric power sector. And this report was also followed by a overview poster, which presents summary of best practices and tried solutions to reduce emissions of SF6. These tools that we're developing, we work together with partners and other companies, technology providers that help us to formulate them, to put them together and share with the rest of the industry. This week, we're also going to be releasing a brief, about 7-page report on alternatives to SF6 equipment. This report was put together by talking to utilities that adopted alternative technologies, as well as technology vendors. And once again, I would like to thank partner utilities and technology manufacturers for providing information for this product that will be coming out by the end of this week on our website. To provide you with a brief overview, the report covers 2 technologies: vacuum circuit breakers and fluorinated gas alternatives. So the report is focused on considerations for utilities, so factors that the utilities have to take into account when considering adopting such alternative technologies. So at the minimum, they are capital costs, operational and maintenance costs, footprint, standards for alternatives, and on-grid piloting. So the report does go over a brief discussion of these factors. However, today you get to actually hear from company adopters and their insights and experiences from vacuum circuit breakers. So please stay engaged. A lot of the information that you hear today will not be available in the summary report. So looking ahead, we hope to deliver more products and information to utilities than you actually need. So I would like to encourage utility representatives to provide technical information or to provide their requests to us, and so that we can start planning our activities, and we would actually consider such feedback. So so please get in touch with us. Tell us about the kind of topics that you want to hear about. In the next few months, we'll also be updating our website. So please check back on our website. We'll try to make sure that you can access our products more easily. So turning back to today's agenda, we have 3 technical presentations, as you see here on the screen. And you'll be hearing from 3 utilities who will share the experience with vacuum circuit breakers in the medium and high voltage range. First, we'll hear from Pacific Gas and Electric, followed by Southern Company and PPL Electric Utilities. So with that, let's move ahead to the next section of our webinar, which is the technical presentations. It is my pleasure to be introducing today Linus Farias and Brian Farmer from Pacific Gas and Electric, and they have a very positive message for us today that it can be done. So I will introduce Linus, who is a senior consulting scientist to lead PG&E's sulfur hexafluoride, or SF6 regulatory compliance program. He has championed PG&E's efforts to reduce the greenhouse gas emissions and environmental persistence risks posed by SF6 for over a decade. Linus is presently coordinating a statewide joint utilities group response to California Air Resources Board proposed regulation to reduce GHG emissions from gas insulated equipment. Linus's experience includes developing programmatic solutions for further environmental compliance within the energy and telecommunications industries. And Linus is joined by Brian Farmer. Brian is a senior consultant electrical standards engineer and a team lead for the circuit breaker team of the substation standards at PG&E. Brian is an active participant in several working groups at IEEE Substations Committee. An electrical engineer by training, he received his master's engineering degree in electric power from Rensselaer Polytechnic Institute and an MBA from the Golden Gate University. In his 30-year career at PG&E, Brian has developed substation asset strategies and managed the substation reliability upgrade program. Brian co-authored numerous papers on photovoltaic systems design and operations. So thank you very much for joining us. With that, please take it away.
Thank you, Olia. I appreciate the opportunity to speak to everyone here, and I'd like to thank the EPA team for providing this forum in this challenging situation we're in. Anyway, go to the next slide, please. A brief background about PG&E. We deliver natural gas and electricity to approximately 5% of all Americans who reside primarily in the northern and central part of California. And our service territory includes Silicon Valley, the agricultural Central Valley, as well as the wine growing areas of Napa and Sonoma. Next slide. So what's our motivation? PG&E's work is driven by our mission and vision to deliver affordable and clean energy while building the energy network of tomorrow. Incorporating sulfur hexafluoride alternatives into this mix is driven by two goals. One being our corporate goal to reduce our operational emissions, and the other being our response to the California Air Resources Board intent to phase out SF6. Go to the next slide. So under our own internal goal, we call it the million-ton challenge, I'd like to focus in on a couple of areas, a few areas which, firstly, we do focus on reducing our SF6 containing, leaks from our equipment that contain SF6. And additionally, we have three actions to support the challenge, the key being the development of a charter and a roadmap to eliminate the future use of SF6 at PG&E. Next slide. This being a busy slide, I did want to highlight the path that we have been on to bring us to this year. Three key elements here. One being that in 2010, California adopted an SF6 regulation to limit the emissions of SF6 from gas-insulated switchgear, culminating in a 1% leak rate limit in 2020. And in 2017, there was a proposal to not only amend that 1% to be a leak limit, but also to initiate phase out of SF6 use in the state. Later this month, the CARB board will hear that formal proposal to adopt regulations that to accomplish those two goals. Go to the next slide. So these are the key elements, to put a comparison between what we have in place today and what we're anticipating coming forward. The key elements here again are that there will be a phase out of SF6 use in the state by the end of 2032. There's also a conversion from a leak rate to a leak limit. It's a mass limit that the state is proposing. And those are two key elements. And then the state is also providing the ability for us to request for exemptions on a case-by-case basis. We'll go to the next slide. So how did we arrive at this point? The key elements here are phasing out the SF6 at different levels for different classes of equipment. As you can see here, this is the table that provides the summary for the transmission equipment. We've actually phased out our use of SF6 in distribution switchgear about a decade ago. Go to the next slide. So looking at how we arrived at this point, we had to convince our leaders about the risks posed by SF6 and additionally the opportunities in terms of what we would gain by moving to alternatives. That took some effort, and like Volia mentioned earlier, there's high risk from greenhouse gas emissions perspective, but also persistence in the environment. We communicated the value of alternatives to many stakeholders, including the manufacturers, the utilities, and regulators. And finally, we're driving the change, leveraging our charter and roadmap that really defines clear roles and responsibilities. And the roadmap itself provides a live way in which we can monitor and track our progress. So with that, I'm going to pass this presentation on to Brian Farmer, who will provide probably the meat, if not more details, on this effort we're on.
Next slide, please. Thank you, Linus. So I'd like to share with you a little bit about our journey in piloting non-SF6 alternatives. Looking at our fleet, we do have quite a large fleet, and about 80% of our breakers are SF6, about 4,000 that we've installed over the last 35 years. So we have a lot in our system. We still have oil breakers, and then the vacuum breakers, you can see we only have 15 of those installed right now, but we have about 50 breakers that are on order and ready to be in the process of being installed. And how did we define our pathway to introduce these alternatives? As Linus mentioned, we developed a SF6 phase-out charter and a roadmap. And the charter really helped to define who the stakeholders were and to define their roles and responsibilities so that we had a more cohesive group in moving forward with the piloting technology. Of course, one of our key players in this process has been our strategic sourcing group, and I'll go into more detail on that on the next slide on how we worked with them. One of the key things that we did differently for this is that we were able to fund some of these pilot projects without identifying a capital project. And that's a little bit unusual, I think, for most utilities. Most utilities, you identify the project, you scope it out, and then you seek funding and approval. In this case, some of our pilots, we were able to get the funding up front, and then we'll have identified the capital projects after that. And that helped to move things forward. All right, next. So this is a little bit of the process we went through in terms of identifying potential suppliers for our vacuum circuit breakers. And we went out and tried to scour the industry and find out what's out there for both dead tank circuit breakers and for what we call GIS. We came up with about 15 suppliers, and we went through a couple of different screening processes in terms of are they providing the type of equipment we're looking for, and are they interested? We ended up with a short list of 10, and we asked them to then invited them to respond to an RFI. From that, we obtained 7 good responses, and you can see those listed there. And then after some further refinement and evaluations, we made a short list down to the 4 at the end that you see there. And we felt those were the highest potential to meet our needs. So then we invited them in to give us more detailed presentations and to see if we could develop some type of relationship from there. So how are we working with the OEMs, the regulators, and the utilities? First and foremost, communication and exchange of ideas is paramount. And to do that, there's a lot of education that needs to be done. There's issues that come up and decisions that need to be made. So a good flow of communication is really quite important. And that includes facilitating meetings with your regulators so that you can kind of get on the same page and understand what each other's objectives are. And then also, I think Linus mentioned about a joint utilities group that we've developed within California to look at working with other utilities and encouraging them to get on board and come to a common platform. Some of the drivers and challenges that we've had in creating this change, I think you can look at this as like a 3-legged stool. The first being utilities, which have to create the demand. If there's no demand, there will be no product. And to support that, it's really beneficial if you have some type of a company policy that will help drive and support the decisions that are being made. And if you can, identify capital projects to recover those costs. And we recognize that there's, when you introduce significant change like this, it can be really challenging. And for PG&E in particular, we've been dealing with wildfire issues and resolving our bankruptcy issue, which I can say now is done, which is great. From the supplier's perspective, they're the ones developing the product, obviously, and they need some incentive. They've got corporate inertia, just like other large companies have corporate inertia. It's hard to change gears, so they need that incentive, and they get that through market demand. They want to see multiple orders coming in, not just from 1 or 2 utilities, but a more cohesive demand. Another thing that was maybe new to some of the suppliers is we were looking for a higher level of engagement, working with them in creating and developing these new products. So that was perhaps another little challenge to work on, is we wanted to be a partner with them and work with them in developing the vacuum breakers. And then the third leg of the stool is the Air Resources Board, or your regulators. And they're the ones who help to set the goals, define what the objectives are, and And in working with that, that's why we developed this California Joint Utilities Group in order to present to the CARB a much more unified voice and help move the process along a little bit quicker. So this is our roadmap in phasing out SF6, and this particular slide looks at dead tank circuit breakers, and I want to focus on just the last two columns, the delivery date and the comments there. On the first line, we've been buying 72 kV breakers from Hitachi for about 3 years now. So we pretty much consider those as a commercial product that's gone beyond the pilot stage. That is our standard now for that class of breaker. And then after that comes at the end of this year, beginning of next year, we've got some orders coming from Mitsubishi for basically the same ratings, 72 kV. So they're well on their way of developing their product. And then we jump up a level to 145 kV and 40 kA, looking for delivery of a couple of orders about mid next year, June of next year. So all those orders are in place. The development is going along, and we're excited to see them materialize on our doorstep. Then the last line there is a development of the next level up, which is 145 kV, 63 kA. And we just went out with an RFP on that. The results have just come in recently, and we'll be evaluating the proposals on that and hopefully making a decision, early next year. Next slide. This slide covers our gas insulated switchgear, and for those who may not be quite familiar with GIS, gas insulated switchgear is where all the breakers, switches, and buswork is all enclosed in gas containing compartments. So it's an integrated system. So we've identified 4 locations where we intend to install GIS, and you can see from the dates that GIS is about a year or so behind the dead tank breakers for adoption here. And these are all rated the same, basically, 115 kV, 50 kA. So we're looking at our first ones toward the end of 2022, and then the next one in 23, and then the fourth one that we currently have lined up would be around 2025. Next slide. So here are some considerations for adopting a new technology. And these are pretty typical, economic, logistics, technical, operational. From an economic perspective, looking at capital versus life cycle costs, we found that it's about 15 to 20% higher capital cost, but we anticipate roughly 20% life cycle cost benefit over its lifetime from reduced maintenance and longevity of the equipment. And of course, when you're looking at economics, the new technology has to compete with off-the-shelf or mature products. And also, you're competing internally with other priorities, like for PG&E, we have a lot of big effort on wildfire mitigation and safety enhancements and system resilience. On planning and logistics, again, it's great to obtain firm commitments from all the stakeholders to utilize the new technologies so that everybody's supporting the effort. And one thing that we did that I think Linus mentioned was we removed the 72 kV GIE from our qualified supplier list. In essence, then now focusing only on vacuum. If you can, one option is to defer projects schedule-wise until the new technology is available. Or if for other projects, you have to also choose projects with schedule flexibility in case there are development issues or other external issues that cause some delays. From a technical perspective, you need to invest in your technical skills of your technicians and your system engineers. We did find that there were some limitations on vacuum breakers, particularly shunt capacitors and shunt reactor applications. So it's important to work with the supplier to evaluate those and determine what you can and can't do, but that's something to be aware of. And from a design perspective, we found that the vacuum breakers are a little bit larger. The tanks are bigger, so that also results in a little bit heavier tank or heavier breaker. And this is not a big issue, but it's something to be aware of. And then finally, from an operational perspective, basically there's really no difference in performance. And that's a good thing, because then now it blends right in with all the other SF6 breakers. We did have some OEM training with Hitachi when we first started buying them to introduce those to our field folks. And then we've also written some field instructions on how to commission non-SF6 GIE. So with that, I'll turn it back to Linus for a very quick wrap up. Thank you.
Thanks, Brian. So just quickly to wrap up here, to conclude, really the drivers were the motivation to change, both from corporate commitments, public expectations, and regulatory mandates. And how we drove the change is through planning, communication, and implementing change management actions to make this successful. So with that, I want to thank you for your time, and I'll hand it over to Volya at this point. Thanks.
Thank you very much, Linus and Brian. I don't see any clarifying questions for you. Somebody did ask if the slides will be available for attendees to download, and yes, they will be available, as well as the recording. So you will be able to access them from BA website, from the partnership website. And I will introduce the next two speakers from Southern Company. The first speaker is Julia Green. She's an environmental reporting and strategy supervisor at Southern Company. She's responsible for developing Southern Company's environmental compliance strategy, associated financial disclosures, as well as both voluntary and federal reporting requirements, including the annual toxics release inventory reporting and the greenhouse gas reporting programs. Julia previously worked for Southern Nuclear Company, where she was responsible for environmental permitting and compliance for the construction and operation of Vogtle 3 and 4, the first new nuclear power generating units that has been constructed in the United States in over 30 years. And Julia is joined by Neil Hutchins. Neil serves as the supervisor of the Southern Company Services Technical and Project Solutions Equipment Services Group. He has over 21 years of experience in transmission substation maintenance. In his supervisor role at Southern, Neil manages purchase of transformers, regulators, SF6 breakers, and GIS. He manages spare equipment fleet and equipment for projects, provides support to substation maintenance groups, substation construction, safety, and training organizations. Neil is a chair or a member of several committees at Southern Company. He's a senior member of IEEE, serving on switchgear committees and alternative gases to SF6 task force. He is also a member of EPRI substation task force. Please take it away, Julie and Neil. Thank you very much.
Thank you, Volya. All right, so at Southern Company, we provide clean, safe, reliable, and affordable energy, as well as customized solutions. We have capabilities in 50 states with 7 electric and natural gas utilities, 9 million customers, and approximately 44,000 megawatts of generating capacity. And we also have approximately 29,000 employees. So to focus in more on the electric generating facility side of the business, we have retail electric companies in Alabama, Georgia, and Mississippi. We also have electric generating facilities in California, Kansas, Maine, Nevada, New Mexico, North Carolina, Oklahoma, Texas, Washington, and West Virginia. Southern Company makes, moves, and sells electricity. So we own and operate our generating facilities. We have natural gas, nuclear, coal, renewables, and hydro. We also own and maintain all of our transmission and distribution systems. And of course, we sell electricity as well. So to hone in a little bit on the carbon focus, we have established an intermediate goal of a 50% reduction in carbon emissions from 2007 levels by 2030, as well as a long-term goal of net zero operations by 2050. And as of 2019, we have reduced our greenhouse gas emissions from 2007 levels by 44%. And included in those greenhouse gas emissions and goals is our SF6. So I'm going to turn it over now to Neil Hutchins to provide an overview of SF6 management and alternatives.
Thank you, Julia. I'd like to thank the Volia and her team at EPA for the opportunity to speak today, and thank also Julia Green for agreeing to present with me as well today. The impacts of SF6 management across Southern Company is the hows are very simply, we're trying to reduce our SF6 footprint. We're improving SF6 controls and processes, as well as implementing non-SF6 technology. Improving SF6 amounts on nameplates is something that we're working with manufacturers to do to have the equipment to be as accurate as possible. We're also sharing best practices across the company as well as within the industry. So we started reducing our footprint back in 2010, roughly, to where we started looking at 38 kV class equipment, and we started to migrate that fleet to vacuum only. Very successful there, that we were able to remove that equipment from the system and replace that equipment. We're at the next bar, as we say, is starting in 2016. We started to implement SF6, a vacuum, clean air vacuum from Hitachi at 72 kV, to where we're limiting and reducing the footprint at 72 kV with clean air vacuum. It's been very successful. We have 2 operate companies that's had experience with that. We have approaching about 8 or 9 of those pieces of equipment in service, and it's been really well. Some of the things that we're able to achieve by reducing the SF6 footprint, we're able to replace older and problematic SF6 equipment. So we're able to do this through capital expenditures, which reduces some of our O&M expenditures. So we're not working on equipment or testing or repairing equipment that's aged out, and that allows us to use the newer technology to move forward and to achieve not only our environmental goals, but some of our O&M spending goals as well. Integrate vacuum technology at 72 kV and below is really been a nice advantage for us here at Southern Company. We feel like that's the wave of the future, that equipment will perform just as the 72 kV SF6 gas equipment. The 72 kV clean air equipment is pretty much a direct swap out. We're also looking at polymer and composite bushings for SF6 and clean air vacuum equipment at Southern Company. We believe that this makes the equipment a little bit lighter, a little bit easier to manage and transport. So we see some advantages with the composite bushings creating better seals and just being a little bit better to deal with than the porcelain bushings. You actually have a nice machined high tolerance O-ring groove and O-ring than you do with the porcelain bushings, where the porcelain itself is the seat for the bushing, which may not be very well machined or very well manufactured. So they could introduce some leak points there and cause the equipment to prematurely leak and require maintenance. Okay, so our non-SF6 equipment that we're looking at, we're in the vacuum, clean air vacuum, or just vacuum. So like I said earlier, 38 kV and less is a complete vacuum technology. We're currently using and employing and implementing the 72 kV clean air vacuum dead tank breaker from Hitachi. We're looking at some other manufacturers that are coming on board with some other equipment. So 2021 and 2022, we hope that a couple of manufacturers are able to come to fruition with some 115 dead tank and live tank equipment or clean air vacuum. We're very excited about that. And those same manufacturers are working toward 2023 and 2024 at 245 kV live tank and dead tank equipment. At this time, Southern Company is really interested in Novec gas. We've done a good bit of looking and investigating of the Novec gas. Just due to the large scale HP issues given this time, we have chosen to move into the clean air vacuum arena due to the fact that it has less HP issues. All this equipment is going to look very similar. The Novec equipment, they've been painting green tanks and green cabinets, which helps. Clean air vacuum for us, it looks like a regular dead tank breaker. So we're working with operations and our training folks to educate our workforce and our system for this new technology. So one thing is we're doing with the clean air vacuum, for our SF6 breakers, we have a G designation on our switching maps at our control centers. We're going to a V designation so the operator knows that that's a vacuum piece of equipment that he's switching or has an alarm or something comes in on, so it makes us a little bit better and a little bit more reactive. So we're also looking at the application to make sure that we apply this equipment properly and doing the homework that it takes to look at vacuum being used to replace SF6. So we've been very successful there, that we do not really see any limitations at 72 kV. We're beginning to look at some 115 kV applications, so we're very excited to move forward with that. And when equipment becomes available and so the company feels that that is a mature technology, we'll be moving into the 115 kV clean air vacuum. Maintenance is going to be a little different with clean air. It's going to be a lot easier. So the O&M we're going to save is that we don't have to have all this process equipment capturing the gas, all the testing equipment that we require today, and the compliance piece is going to get easier with the clean air vacuum as well. So we looked at that we'll be able to save some money over the life of the asset that we're spending with the SF6 version of the dead tank breaker versus its clean air technology counterpart. And one of the two main reasons that we're looking, to not move into the Novec gas is its limited availability, and it requires specialized equipment and training that we believe is better to invest that in the clean air technology with vacuum currently. So as we improve things and make things better, we plan to drive improvements with manufacturers and throughout the industry. We still want to make sure that our nameplates for SF6 equipment are very accurate, or as accurate as possible. So we're working with our key vendors and manufacturers that provide us with SF6 equipment. That includes dead tank, live tank, and GIS. We're also, some manufacturers are looking to improve and to have gasket redesigns to make equipment leak less and less prone to leaks. And we're also setting expectations of a leak-free, low leak rate with approved manufacturers to get the best equipment we can on the system, so that we don't have to worry about leaks in the future. One of the big things I will stress is, have a plan for integrating non-SF6 equipment into your system. Do some homework, talk to some of these utilities that you see present today, to see what their obstacles were, what were some issues that they had when they went down this road, and how they resolved those issues to make it as positive an experience as possible. When you change technologies, oil to gas, it was easily recognizable, visual. You won't have all those cues that we had in the past for changing technologies with this clean air vacuum or Novec technology that you may be choosing to move to as you move away from SF6 and become a little bit more environmental savvy and reactive. So we are sharing the best practices with our opcos within Southern Company, and we're all reaching out to our peers and our industry partners to let them know what we're doing here at Southern Company, and we're gaining information from talking to other companies. And we're also looking at, the new technology and evaluation adoption of newer non-SF6 technology a little faster than we have in the past, to kind of mirror to what Julia was sharing with our environmental focus. One of the biggest things, we are aware of HP issues. This equipment looks the same. It's going to be very hard for the workforce to differentiate between the equipment, but we're doing things with stickers and badges and signs that make it easier and a little bit more robust in our system, that we don't get confused if is this a gas breaker, or is this a clean air vacuum, or is this something else. We're training on new technologies and processing requirements of the new type of equipment. We're implementing that now, so that our workforce will be well trained. And we're looking at, are there any things to be aware of when an SF6 equipment and a non-SF6 piece of equipment is on the same bus, the same line, or the same facility? We want to fully understand the performance of the non-SF6 equipment. We want to make it safe. We want to recognize and train to the failure modes of this equipment. And we also want to be able to trend, test, and investigate the non-SF6 equipment, just like we do the SF6 equipment, to know where the problem's at, to know what we need to be working on, and where our focus is at.
Thank you very much for this insightful presentation, Julia and Steve. I do not see any clarifying questions, and we will move on to our next presenters from PPL. We have Joseph Luca, who's a manager of project development and standards at PPL Electric Utilities. Mr. Luca is an experienced leader in engineering design, construction, and project management. Current responsibilities include managing a diverse team of professionals responsible for transmission and substation project strategies and technical standards. His team's responsibilities include implementing new technologies into the portfolio, like medium and high voltage vacuum circuit breakers. And Joseph is joined by Kyle Stupinski, who is a manager of transmission system reliability at PPL Electric Utilities. So his current responsibilities include leading a team of field engineers responsible for the maintenance and commissioning of new substation and transmission assets. Responsibilities of groups ensure good management of SF6 inventory, tracking, and maintenance of existing equipment. So thank you very much. Please, Joseph and Kyle, take it away from here.
All right, so I want to thank everybody for letting PPL, and sorry about the technical glitches there. I wanted to thank everybody for letting us, on behalf of PPL, join and be part of this partnership, and thank you, the EPA team and all the guests out there. PPL, we're excited about the opportunity to share a recent update with the update of SF6 reduction, and specifically most recently for us, that's installing a vacuum circuit breaker on the transmission system in 2020. So just a brief update on the PPL Electric Utilities and who we are. We serve 1.4 million customers in 29 counties in eastern and central Pennsylvania, over 50,000 miles of power lines, 10,000 square mile service territory. We do not produce any power, but we transmit, distribute through our transmission lines, substations, and distribution lines. PPL Electric Utilities is part of a parent company, PPL Corp, a Fortune 500 company, over 12,000 employees, and more than 10 million utility customers in the US and UK, mainly made up of three large parent companies, with PPL Electric in Pennsylvania, LGKU in Kentucky, and WPD in the UK. So why are we here? At PPL, we definitely have a partnership with our customers and community on a sustainable future for all of us. As mentioned from the first couple presenters today, biggest focus here is reducing our SF6 footprint and utilizing alternative technologies when possible and capable. In previous initiatives, we really focused on the process oriented, controlling leaks, process of handling, transmission, and really focused on the medium voltage at the distribution level. We're shifting that focus right now into eliminating that risk on our transmission grid and taking the alternative technologies to the 69 kV through the 500 kV class, which is our transmission system. So as mentioned earlier, definitely the SF6 and the components and the impact with CO2 in the atmosphere and all the other environmental benefits of being non-toxic, non-flammable, and eliminating, reporting, and recycling and handling issues through SF6. But not only besides the environmental impacts, but also reliability. So as Brian and Neil had mentioned, vacuum technology provides other benefits. Some of the bigger benefits is just number of maximum operations before the interrupter replacement, faster interrupting time, and performance based at the rated nominal current or rated short circuit current for longer durations through the life cycle of the breakers. So long term, this leads to less maintenance and longer use, which is good for customers, good for PPL as we minimize our maintenance long term. Proven technology, so vacuum, as the previous utilities had mentioned, vacuum at the medium voltage or distribution has been around for a while now. At PPL, we've really been focused at eliminating the other, whether that's gas or oil, which is the mixture of our fleet, just like everybody in vacuum. Definitely at the distribution level, we've made a pretty big leap in the past 5 to 10 years at pushing to vacuum. And we plan to keep moving this push, but we also plan to make a pretty big push on the transmission system. As I had mentioned, is we're just getting in that at the 72.5 kV class. All right, so we talked about environmental and we talked about reliability benefits. There's also cost benefits long term, as PPL did a pretty extensive evaluation during our pilot project and phase in the previous 3-4 years as we've been looking at vacuum technology on the transmission system. So we're really excited to be here, and from a cost standpoint, we really believe long term there'll be a total cost of ownership benefit for switching over our fleet on the transmission system to vacuum. As mentioned before, there is some initial capital cost differences versus the SF6, which has been out in the industry for years and been reliable. But as more companies switch over and vacuum increasingly penetrates the marketplace, we believe these initial costs will also come down. All right, so I mentioned a little bit about our pilots. So we've partnered with 3 different vendors and continue to partner with 3 different vendors. Our first vacuum pilot this year showed up on the transmission system and was installed in June of 2020. Our second, very shortly after there, in July, was installed. Very proud that these breakers were the first permanently installed breakers in Pennsylvania at this voltage class. And in 2021, we have a plan of 25 or more vacuum circuit breakers to be installed on our 69 kV system. One other, so our first pilot this year was with an OEM, Hitachi, and one of the other benefits that we're seeing is just a long history. Is this at 72.5 class has been out there a while too, and the mean time between failure is really a differentiator between the SF6 and vacuum, and the history that already exists in North America and worldwide. All right, as mentioned before, 72.5 is available, and multiple vendors are coming on with availability later this year and next year. And then we're working with multiple vendors to push our vacuum technology into the 115 and 145 class in 2021 and 22. And we're hopeful, there's still a lot of work to do, that we could partner with these same vendors from preliminary partnership in the 2024-2025 timeframe from at least a pilot level technology up to 245. And I'll hand it off to Kyle to continue the discussion on our SF6 alternatives. Thank you.
Thanks, Joe. Good afternoon, everyone. I'm going to be speaking on our PPL SF6 Sustainability Program. PPL's program is driven by a partnership and commitment to deliver both reliable service to our customers through responsible environmental stewardship. This effort is ingrained in our culture and through corporate values focused around advancing a clean energy future and leveraging tomorrow's infrastructure today. Our overarching goal as a company is to reduce CO2 emissions by 80%. Since SF6 is an extremely potent greenhouse gas, approximately 23,000 times as impactful as CO2, this has been and will continue to be a focus area for us. Our employees have really taken pride in leading SF6 reduction techniques on our system. Holistically, looking at PPL's SF6 program and reduction efforts, it's really focused around 4 principles. These principles are similar to the EPA's best practices and have helped us drive results within our organization. It boils down to accountability and ownership, systemic equipment tracking, consistent and prescribed actions, and continuous learning from SF6 loss events. Leveraging these principles, we have put structure in place to drive a self-fulfilling process with the goal of ensuring we are learning and implementing corrective actions for all SF6 loss events on our system. When reflecting on our program, there are a few key areas which have been instrumental in driving success, and I wanted to take a moment to share those with you. The first key area was implementing consistent and prescribed actions. We worked with our data analytics group to really understand the behavior of our SF6 equipment fleet and leak performance. Through these efforts, we were able to develop a cadence for replacement and implement a yearly circuit breaker replacement program, which is fueled by operational and leak data. We now spend less and less time trying to fix old, antiquated first-generation SF6 equipment when the data shows it really won't be a reliable long-term solution. We have moved towards emergent replacements for this type of work. The second key area is really managing and measuring our performance. Since we set up a data-driven maintenance and replacement program coupled with a process to respond to SF6 loss events, it was a natural fit to really measure and assess in an actionable way where we are improving and how we were actually improving our performance year after year. Our measured performance was then used to assign stretch goals and really help drive accountability to our field teams through the achievement of results. We wrapped this effort up with a few key performance indicators and a dashboard for constant visibility of our performance and our follow-up actions. When you look at performance, results are what matters. We are proud of our SF6 program and have come a long way in the past 5 years. We are still seeking to improve and always looking for opportunities to benchmark with our peers. Some of the key performance indicators we look at when measuring performance are industry standards. Examples of this include overall pounds of SF6 lost, leaks and fills per device, and the most targeted, which is an overall percent of your SF6 loss rate. The reason we feel this is a good metric is it provides an overall comparison of your actual SF6 loss versus your actual system capacity, very similar to a health index in a sense. In this key metric in 2015, PPL was deep in 4th quartile with a system loss rate of approximately 1.15%. Fast forward to 2019, we are projecting to be in top decile performance with a system loss rate of 0.23. I and PPL really appreciate your time this afternoon and the opportunity to present on this topic we're really passionate about. With that, we're happy to take any questions. Thank you.
Thank you very much, Joseph and Kyle. I'm not seeing any clarifying questions, so I'm going to go ahead and close this section of our webinar. If you do have questions, please type them in the chat box. We will read out questions. I'll read out questions as they come out. So we'll move over to the next session. I want to thank you all the presenters for the wonderful presentations today. I thought they were very insightful and just fascinating to read about, to hear about your efforts at your companies. So moving on to the next question. Just a reminder to everybody, the chat is open. Please type in your questions in the chat box. If you're not able to access the chat box, please email the partnership at SF6 partnership@epa.gov. I'll monitoring that email as well, so I'll be able to read your questions. But for now, we're going to go ahead and start it with a Q&A session. The first question we have is for PG&E, and the question is, so I want to make sure that Linus and Brian are online with us. So the first question is, how did PG&E handle the technical limitations of vacuum breakers regarding shunt capacitor and shunt reactor switching and protection? Linus and Brian, are you able to handle that question?
I think that's going to come my way.
Okay.
Well, first of all, shunt reactors and shunt capacitors are a small subset of the applications of breakers in the system. Most breakers are used for line protection and transformer protection. So currently our position right now is that we are not using vacuum breakers for those two types of applications, for shunt reactors and capacitors. We are still using SF6 at this point till further developments can be made, or other technical changes that would permit us to use them for reactors and capacitors.
Okay. Thank you very much. The next question I have is for PPL. Who are the three vendors selected by PPL for the pilot SF6 free PCB?
Yeah, no, thank you. I mean, so we've worked with 3 different vendors on the vacuum technology, no different than what Brian had mentioned earlier. So our first pilot was with Hitachi, and then we were working with Mitsubishi and Siemens for future pilots in 2021.
Thank you very much for that. The next question came in the chat. We remind you, you can utilize the chat to ask questions if you'd like. So the next question is, to mitigate crew confusion between SF6 and dry air, have you considered specifying a different fill valve for each?
So this is Brian Farmer again at PG&E. Yeah, the issue about fill valves has come up. We have not decided to standardize on a specific valve, and part of the reason for that is our SF6 suppliers that we've had throughout the years have different valves on theirs. We don't have a standard, so we don't have a single standard valve for SF6. So what we've allowed Hitachi to go ahead and use their standard for the vacuum, and what we've done is apply a warning plate adjacent to the valve to indicate that this breaker uses dry air, not SF6. So that's our approach at this point.
Okay, thank you very much for that. But in the meantime, we're going to move on to the next question for all the 3 presenters. And the question is, how are field staff being trained to handle both SF6 equipment and vacuum breakers? What are some of the best practices to distinguish between the two?
Hi, this is Kyle. I can speak for PPL. So much of our distribution circuit breaker fleet is all vacuum right now. So 69 kV isn't essentially that much different. So when we're commissioning an asset, each different manufacturer and type of breaker has like a different commissioning form and acceptance criteria. So that's very clear and black and white as we're energizing and bringing something in for service. Then during the maintenance and sort of troubleshooting, we have DDI specific to each type of equipment on our system. So if it's a SF6 circuit breaker, we'll get an SF6 sort of troubleshooting sheet along with the DDI which is sort of like your work method on how to troubleshoot it, maintain it, and to repair it. So very similar to basically what we're doing for our vacuum circuit breaker is we're just sort of carrying that on our distribution fleet, carrying over that methodology to our transmission fleet as well. So we don't have a large number on our system yet, but so far so good.
Great, thank you so much. Perhaps somebody from PG&E is able to answer that, and if Southern is Neil is still unable to unmute himself, perhaps we can type in the answer and I can read the answer to that one as well. So thank you, Neil. I saw you already typed in the answer for the last question, so I'll read that out next. Thanks.
So again, this is Brian Farmer, PG&E. We haven't, let's see, I have to remember what the question is.
Sure, I'll read it out again. So how are field staff being trained to handle both SF6 equipment and vacuum breakers? And so what are some of the best practices to distinguish between the two?
Okay, I think it was Joseph that just was speaking.
Okay.
Similar to PPL, we've had vacuum breakers on our distribution system, our distribution class for many years. So we are familiar with working with vacuum. One of the things I think we are looking at implementing is a vacuum integrity test. And we're still working with one of our manufacturers on developing that. But basically it would be like a high pot test just to make sure that during transit and installation something didn't happen to break the vacuum seal somehow. But other than that, it's pretty standard. We're implementing or using the same commissioning processes as we would for an SF6, to my knowledge. I'm not as familiar with the maintenance, so I don't know all the details, but I know that one vacuum integrity test is one thing we're looking at.
Okay, thank you very much. And in the meantime, I have not heard from Southern on this specific question. However, Neil did text in the response to the previous question on the mitigating confusion between SF6 and dry air. And the question was whether you've considered specifying a different fill valve for each. And to answer to that, Neil said Southern companies already using different connections and labeling to differentiate between SF6 and non-SF6. So that's something that's already been used by Southern. The next question, it's more like a comment for Patrick DeLillo from ConEd. If you are doing a HEPA test, is there an issue with X-ray generation?
I think that's maybe a better question for the manufacturers to supply.
High potential. Oh, that's what that means. High potential.
High pot, yeah, high potential. I don't believe so. I think some of the data that I've seen is that the X-ray generation at normal operating voltage is well below standard guidelines, and when you're doing a high pot, we're not increasing it that much. But it's a good question. Maybe does need some follow up. Okay,
then we'll probably get back to you, Pat, on that. I'm going to move on to the next question to all presenters. What do you suggest to other utilities looking to adopt alternatives and needing the corporate buy-in, particularly for utilities that might not have the state regulatory drivers to move away from SF6? So again, what would you suggest to other utilities looking to adopt alternatives, how they can obtain their corporate buy-in if they don't have any other drivers?
Maybe I can take a stab at that to start with. This is Linus with PG&E. Really what we found is communication. There's the cost factor that is an item to consider, but communicating that it is a safer solution. You don't have the SF6 byproduct risk, and inherently, at least with a vacuum break as opposed to a pressurized vessel, at least on the inside, you have a reduced risk of other types of explosive failure. You do have pressure on the dry air side, but those are some of the reasons why I think it does make good sense in the long run to move away from it. And then of course the maintenance costs go down, and you know, you add in the climate risk and the persistence of SF6 in the environment. Those factors all together make a good case for moving away from SF6 into an alternative.
Okay, thank you very much. Anybody else wants to respond to that?
Hey, this is Julia with Southern. I'll just echo what Linus said. I completely agree. If you can do a life cycle analysis and really show over time how the total cost, capital and O&M, is lower with the non-SF6 alternatives, I think that's really helpful. Again, communication, like Linus said, and the environmental benefits. You know, if you have carbon goals in your company, then, you know, it shows how you can help achieve those carbon goals by reducing your SF6 footprint.
Okay, thank you very much, Julia. Any insights from PPL that you would care to share?
Yeah, I mean, I would echo both of the other presenters there. It's really focusing on cost and environmental impacts with the goals for a more sustainable future. Really communication, but total cost of ownership definitely will help sell to leadership. Or in Pennsylvania, we don't have any state requirements for SF6 reductions any more restrictions, but it's still part of our goals for just long-term future for sustainability, and definitely from a total capital cost and O&M cost, there's a lot of benefits there.
Okay, thank you all presenters for those insights. A question that just came in: what is the cost differential between SF6 breaker versus a non-SF6 breaker? I think somebody presented that, but if you take a minute to summarize.
Yeah, hi, this is Brian Farmer again. Well, of course, there's always contingencies on that. Depends on the rating of the breaker and the manufacturer, but so there's not one single answer, but we're finding around 15% so far. I think as you get to the higher voltages, that differential may increase, but it's a little hard to tell because a lot of the breakers are still in the development phase and, you know, not really commercialized yet. We only have one commercial product really available right now.
Mm-hmm. All right.
Hey, this is Vernon Toops from Siemens. I also consider what you're talking about now is not so much commercial costs, but you have a lot of pilot projects going on now too. So as Brian said, as the breakers become more commercially available, the hope is that the price will go down as the numbers increase as well.
Okay, thank you very much for weighing in, Siemens. And we have just one last question, perhaps. Oops, actually, no, we probably have to wrap up. We do have 2 more questions. I will try to get back to those who are able to, who asked us those questions to us. But I apologize for the late start a little bit. We had a little bit of a rough start, but we've managed to catch up, and we're still able to finish on time. So thank you for those of you who stuck to the very end. And most of you did, in fact, the very vast majority. I do want to thank our volunteer speakers today for sharing their experiences. It's because of such active partners like you were able to offer resources to their partnership. And I want to thank you all for your attention and for your continued interest in an effort to reduce emissions of SF6 in the electric power systems sector. If you have any questions, please feel free to email the partnership at this email. Any ideas and any ideas you have about a collaboration or ideas for products that you would like to see, please feel free to get in touch. Again, thank you so much for listening in on this webinar, and we'll look forward to staying in touch with you. Thank you.